There's actually quite a bit of complexity involved in TCP communications. When you think about it, you have a number of layers: the data link layer, the network layer, the transport layer, the application layer, all involved in this communication, and they all have to coordinate with one another. You have MAC addresses at the data link layer, you have IP addresses at the networking layer, you have TCP at the transport layer, you have ARP that sits between the data link and the networking layer. And so these are just a few examples. There are other protocols and functions that are all happening in concert with one another. So let's take a look at the host-to-host packet delivery process using TCP and simplify this to some degree. And as we go through this, we're going to see exactly how data is transferred on a network, how two end systems can coordinate this packet delivery. So we're going to begin with two computers on the network that want to talk to each other. Now we're going to have some supporting cast here. So we're going to have a DNS server that's going to provide some resolution for us. Now in this example, let's assume that we have an application that is running on our computer that wants to send some traffic. Now, the application says, okay, I've got this data put together. Maybe it's an email, maybe it's Telnet, whatever the case may be. I have some traffic and I need it to be sent reliably. Now, I want to set up a connection to 192.168.3.2. Now, if we look at this topology, 192.168.3.2, this is the destination. So the application passes off the data to the application layer of the OSI model, or the application layer of the TCP/IP stack. Now, let's assume this is the TCP/IP stack, so we're going to skip the presentation and session layers. So we go from the application layer, and the application layer says, okay, I need to send this reliably, so I'm going to use the transport layer, which provides me reliable service. And so the transport layer says, okay, not a problem. I'm going to go ahead and use TCP. Now remember, TCP is the connection-oriented service, and we need this to be sent reliably with sequence numbers and acknowledgments and all that good stuff. So the transport layer instructs the TCP protocol to set up a session to 192.168.3.2. Now you might be wondering, how does this machine, and even this application, know what address the destination is? How do we know that 192.168.3.2 is who we want to talk to? Well, that's where this little DNS server comes into play. You see, let's say we're sending an email, and the email needs to establish through a mail server. Well, when we plug in our mail server settings, we're going to plug in a fully qualified domain name. It might be mail.something.com. And so we're going to resolve mail.something.com using DNS, which might point us to 192.168.3.2. So that DNS is just a separate application. Okay, so let's just say that we've got this transport layer that's now going to set up a TCP session for me. So TCP, if it were a person and could speak, it would say, hey, TCP/IP, let's send this TCP SYN to 192.168.3.2. Now at this point, what's going to happen? Well, the next thing to happen is that the IP layer, the network layer, it says, okay, no problem TCP, I'll go ahead and send that SYN packet, or that SYN segment, to 192.168.3.2. So IP says, I need to pass this down to layer 2. Well, as it's passing that down to layer 2, it's got to add some header information. So we're trying to keep track of this. So it puts its source IP address in the header. It puts the destination IP address in the header. And it also includes the TCP header that was passed down from the layer above, which has that little flag toggled in it that says that this is a SYN. Okay, so now the IP protocol has told layer 2 to send the packet to 192.168.3.2. Before layer 2 can do this, it needs to make sure it has an ARP cache entry. So layer 2 says, hey ARP, do you have an entry or a mapping for 192.168.3.2? Now in this case, ARP might say, yes I do, and then we can go ahead and create the layer 2 frame. In this case, ARP says, well, let me look. Is 192.168.3.2 in my ARP table? ARP consults the ARP cache or the ARP table. It finds that it is not there. So ARP says, I guess layer 2 is going to have to put the packet in the buffer, kind of in a parking lot. It's going to store it while I do an ARP. So ARP goes to work. He says, I'm going to go ahead and send out a message. So that packet that we want to send is now sitting in the packet buffer. And ARP creates an ARP request. That ARP request says, hello, I am 192.168.3.1 and my MAC address is 0800.0222.2222. Are you 192.168.3.2? Now you have to remember that this is a broadcast, so he's sending it out to everybody. Now ARP says, okay layer 2, go ahead and send this ARP message using our MAC address as the source, and for the destination, make it all Fs. That's that broadcast address. So we can see the destination is the broadcast address, the source is ourself, and this is an ARP request, and so we send that out onto the wire. Now the original packet, that TCP SYN that we were asked by the application to set up, it's sitting there in the packet buffer this whole time. So layer 2 says, all right, it's sent, and now we're just waiting. That frame travels across the wire as a broadcast, and any other machine on the layer 2 network hears this broadcast. So in this case, it's the device that we intended to receive the ARP request. So layer 2 on our receiving device says, hey, I just got a frame. It's got a broadcast MAC address on it, so I'm going to have to process it. I need to look at it. It's for everybody. The protocol ID says that it's an ARP. Let me strip off that layer 2 header and send it up to the ARP application. So we strip that off. Layer 2 says, hey ARP, here's something for you to take a look at. ARP says, okay, that is an ARP request from 192.168.3.1. Now that I heard from him and I know his MAC address, let me put that in my ARP table. And then that way I can respond to him and say, yeah, that's me. So now ARP says, okay, I need to put together an ARP reply that says, hi, I am 3.2 and my MAC address is 0800.0222.1111. So then ARP says, okay, layer 2, can you send this ARP reply using our MAC address as the source and send it directly back to 0800.0222.2222. No need to broadcast this. Send it directly to him. So layer 2 says, all right, it's sent. And the packet is now on its way. Now on the other side, layer 2 receives that frame. He says, okay, this has my MAC address. I have to process it. And the protocol ID tells me that this is an ARP. So now let me strip off the layer 2 header, and I'm going to send that on up to ARP. Hey ARP, here you go. I got something for you. Now ARP says, okay, this is an ARP from 192.168.3.2. It's an ARP reply. Now I can add its IP and MAC address into my ARP table. And remember, that can be viewed on a Windows or a Linux machine using the ARP-A command. So ARP says, hey layer 2, I now have that mapping you needed. 192.168.3.2 is now mapped to 0800.0222.1111. So now we can send that packet that's in the packet buffer. So layer 2 builds the frame for me. And we can see in the frame that's now built, we have a couple of items of relevance. There's that original TCP SYN. That's my layer 4 information. That's my transport layer information. Then I have my source and destination IP address. That's the network layer or what we might call layer 3. Then we have the source and destination MAC information. We might call that layer 2 data. And the source and destination MAC are specific addresses. This is not a broadcast. This is a unicast. Okay, so layer 2 says, all right, I can send that pending packet, and it gets sent across the wire. Now, when the receiving computer sees that frame come in, he goes, oh, okay, I got something. It's got my MAC address on it. And so this is for me. That means that I need to strip off the layer 2 information and pass whatever's left up to the network layer. The network layer looks and he goes, yep, that destination IP address, that is me. So I need to strip off the layer 3 information and pass it up to the transport layer. Now, when it goes up to the transport layer, remember at layer 3, or at the network layer, in the header we had a protocol field. The protocol field indicated that this was TCP, so it says, here you go TCP, I got something for you. TCP looks at this and says, oh, okay, I need to now send a SYN ACK to the TCP SYN that you just handed me. I need to reply back because we're doing a three-way handshake. So now TCP says, here you go, send this. And it gives me a TCP SYN ACK. We pass that down. We add a layer 3 header, which includes the source and destination IP address. Pass that down to the data link layer. The data link layer now adds the destination and source MAC address and then forwards it out on the wire again. So now that gets to the other side. TCP is going to eventually receive this frame again, gets the SYN ACK and says, all right, I got it. He ACKed me, and now I'm going to have to reply back to that with an ACK. So I need to let him know that I got his SYN ACK, and this will complete our three-way handshake. So now TCP creates a ACK that is going to go back to 3.2, passes it down to the network layer, which adds the layer 3 header with source and destination IP. Layer 3 passes that down. Hey, data link layer, I need to send this. Data link layer adds source and destination MAC address information into its header and then sends it out on the wire. Gets to the other side, and we're good. So at this point, we've done the three-way handshake, and layer 4 can now report back to the application, hey, I've set up your session. Now, everything we've done up to this point is just setting up the session. Now it's time to send the data. So the application says, all right, here you go. This is that application data that I wanted you to send. And now the TCP protocol is going to set up that application data to be sent in the reliable connection. So it adds a sequence number on here, passes it down to the network layer. The network layer adds source and destination IP, passes that down to the data link layer, adds source and destination MAC, and then passes that out onto the wire. It gets sent across the wire. As it comes into the next device, the receiving device sees a frame. That frame has its MAC address as the destination, so it strips it off, passes that up to layer 3, takes a look at the source and destination IP. Yep, that's my IP right there. I'm going to go ahead and strip this off. The protocol said it was TCP, so I pass it up a layer to TCP. TCP looks at the sequence number and says, okay, I got this data. I can hand the application data right up to the application, and at this point we would need to send an ACK and say, yep, I got that data. Now the ACK is going to be one number higher than the sequence number. So assuming this is the last byte that was sent, it was a number 3. He acknowledges that. He says the next thing I expect to see from you is number 4. So he sends an ACK back. There's no data carried here at this point. The ACK is for add my layer 3 headers, add my layer 2 headers, send it out on the wire, and now I've just established host-to-host communication using TCP.